So problem number 1b from 10.8, we have this initial value problem, y double prime minus 4y prime plus 13y is equal to delta times t minus pi over 4. And we have the initial conditions, y sub 0 is equal to 3 and y prime of 0 is equal to 0. So taking the Laplace of both sides, you get s squared Laplace of y minus s y0 minus y prime of 0 minus 4s Laplace of y plus 4y of 0 plus 13 Laplace of y is equal to, and taking the Laplace of that just turns into e to the negative pi over 4s. And then combining all the terms in front of the Laplace of y, you get s squared minus 4s plus 13 Laplace of y minus, since our y0 was 3, you get minus 3s plus 4 times 3, which is 12. So minus 3s plus 12 is equal to e to the negative pi over 4 over s. And then isolating and solving for Laplace of y, you get Laplace of y is equal to e to the negative pi over 4s over s squared minus 4s plus 13 plus the 3s minus 12 over s squared minus 4s plus 13. This doesn't factor nicely, so you have to complete the square. And when you do, you take negative 4 divided by 2 and square it, and you get plus 4 minus 4 plus 13, so you get s minus 2 squared plus 9. And then rewriting it, you get Laplace of y is equal to negative e to the negative pi over 4s over s minus 2 squared plus 9 plus 3s minus 12, which I split it into 2. So I get plus 3s over s minus 2 squared plus 9 minus 12 over s minus 2 squared plus 9. And then this one, this middle term, I'm gonna try to make it into a cosine. So I took the 3 out, and in order to make it a cosine, I needed an s minus 2 at the top. So when I do that and I distribute back then, I have a extra minus 6. So I have to add a 2 in. So when I distribute the 3 in, I get a plus 6, and the value doesn't change, and I just get 3s at the end. So rewriting that, I get Laplace of y is equal to e to the negative pi over 4s over s minus 2 squared plus 9 plus 3 times s minus 2 over s minus 2 squared plus 9 plus 2 over s minus 2 squared plus 9. Again, the value of the middle term doesn't change. And then the minus 12 over s minus 2 squared plus 9 just stays the same. And when you distribute this 3 in, you get plus 6 minus 12, both have the same denominator, and you can just combine them to get a negative 6 over s minus 2 squared plus 9. So you get Laplace of y is equal to e to the negative 4 over pi over 4s over s minus 2 squared plus 9 plus 3 times s minus 2 over s minus 2 squared plus 9 minus 6 over s minus 2 squared plus 9. Now the first term, it's a second shifting theorem, and you get y is equal to u sub pi over 4 and then e to the 2t, but we have to change all the t's to t minus 4 pi over 4. So you get u sub pi over 4 e to the 2 times t minus pi over 4, and then this part right here, if we have a 3 up here, will be a sine 3t. So it'll be sine 3 t minus pi over 4. However, if I'm putting a 3, if I'm multiplying by 3 up here, I have to multiply by a 1/3 at the bottom. So this whole first term becomes u sub pi over 4 e to the 2 times t minus pi over 4 over 3 times sine 3 times t minus pi over 4. Now this second term, it's from a first shifting theorem. So you have a cosine, but it's shifted by e to the 2t, so 3 times e to the 2t and then cosine 3t. And you don't have to do the t minus pi over 4 since it's not a second shift. And the last one, it's also a first shift. So you get e to the 2, it's shifted by e to the 2t again, as you can see. And if I have a 3 at the top, it'll be a sine. So basically I can rewrite this saying that it's a 2 times 3, which is 6. So I get minus 2 times e to the 2t sine of 3t. So our final answer is y is equal to u sub pi over 4 e to the 2 times t minus pi over 4 over 3 sine of 3 times t minus pi over 4 plus 3e 2t cosine 3t minus 2e 2t sine 3t.